back in late 2020, the cybersecurity world was absolutely rocked by the discovery of one of the most sophisticated cyber espionage campaigns we've ever seen. And look, this wasn't just another hack. This was a masterfully executed digital heist that struck right at the heart of the supply chain, turning a tool that thousands of companies trusted into a powerful weapon.
So at the center of all of this was a company called Solar Winds. Their IT monitoring software, Orion, is used by organizations all over the world. The attackers managed to sneak a backdoor into a totally legitimate software update, which then got pushed out to a staggering 18,000 of their customers. We're talking major corporations, U.S. government agencies, global organizations, all of them suddenly potentially compromised. But here's where the plot really thickens. This wasn't some chaotic smash-and-grab job. Nope. Even though they had a foothold in thousands and thousands of networks, the attackers, a group we know as APT-29, were incredibly selective. They only activated their most advanced tools on a very small, very specific list of high-value targets. It was a surgical operation, through and through. So here's what we're going to break down. We're going to look at how they built the perfect digital Trojan horse. We'll go inside SolarWinds' own build servers to see where the magic happened. We'll unpack the two main pieces of malware, Sunburst and Teardrop, and then we're going to step into the shoes of the security analysts who had to figure this whole mess out. And finally, we'll talk about the crucial lessons we all learned from this. All right, first up, let's dig into the core strategy here. The absolute brilliance of this attack is all about how it turned trust, the very foundation of software, into the biggest vulnerability of all. So what we're talking about here is a classic supply chain attack. Think about it. Why try to breach the heavily fortified walls of thousands of different organizations, one by one? Instead, the attackers went after the one company that already had a key to every single one of those gates, the software provider, Solar Winds. By poisoning the source, they let the stream carry their malware everywhere. And this timeline, wow, it really shows you just how patient these attackers were. This wasn't a quick job. They started laying the groundwork way back in August 2019, registering the command and control servers they'd use later. They got their initial access in September, and get this, by October, they were already doing test runs, injecting harmless code just to make sure their method worked without breaking anything. It wasn't until March 2020, months later, that they finally deployed the real malicious payload. Okay, to really appreciate the sophistication here, we need to go inside the SolarWinds build environment. This is the heart of the operation. This is where the crime was actually committed. You know, the real genius here, the masterstroke, was that the malware was digitally signed by SolarWinds themselves. By injecting their code right into the official build process, the final malicious update got stamped with SolarWinds' own trusted digital signature. To any security software looking at it, it appeared completely authentic. And a special tool they built to pull this off was a piece of malware called Sunspot. Now, the best way to think of Sunspot is like this tiny, specialized robot on a factory assembly line. It had one job and only one job: wait for the perfect moment and then swap out a part to sabotage the final product. And the way it worked was just elegant. It was a four-step dance. First, Sunspot would just sit there, silently monitoring the build server, waiting for the process that compiles the Orion software to start. Second, the moment it saw that command kick off, it sprang into action. Third, in less than a second, it swapped a clean, legitimate source code file with its own malicious version. And fourth, the build process just carried on like nothing happened, compiling and digitally signing the now infected code, which now contained that Sunburst backdoor. Okay, so the poisoned update is out in the wild. Now let's talk about the payload itself, the backdoor they called Sunburst. Right, so this is the malware that landed on the systems of those 18,000 customers. It was the perfect sleeper agent designed to quietly set up a base inside a victim's network and just wait for instructions. Sunburst was all about stealth. Once it was installed, it would do nothing, just lie dormant for up to 2 weeks to avoid setting off any immediate alarms. And when it finally did call home to the attacker's servers, it disguised its network traffic to look exactly like legitimate activity from the Orion software. Its main job was reconnaissance, figure out where it was, see if it was an interesting network, and then report back so the attackers could decide if this was a target worth hitting again. And that brings us to the second stage, which is where things got really serious. Because for that handful of targets the attackers were truly interested in, they needed a much more powerful tool. You see, once Sunburst phoned home and confirmed, hey, we've landed in a high-value target, It acted as a delivery mechanism. It was used to drop a second, more flexible malware called Teardrop. This was the tool for the hands-on keyboard part of the mission, moving around the network, stealing credentials, and ultimately stealing data. So, just to put it all together, let's recap these three key players. You have Sunspot, the inside agent working at the factory to inject the backdoor. Then there's Sunburst, the sleeper agent that gets deployed everywhere to establish a quiet foothold. And finally, you have Teardrop, the special ops tool that was only used on the most valuable targets to carry out the main mission. Okay, so now let's flip the script. Let's put ourselves on the other side of the fence. The attack has happened. The alarm bells are going off everywhere. How in the world do you, as a defender, even begin to untangle a mess like this? So imagine you're a security operations center analyst. You walk in one morning, grab your coffee, and then the news breaks. You know your company uses Solar Winds Orion. Your phone is blowing up. What do you even do? Where do you possibly start?
Well, the first thing is triage, and it is an absolute race against the clock. You're scrambling to do a frantic inventory. Find every single machine running those vulnerable versions of Orion. Next, you have to operate under the worst-case scenario. Assume every single one of them is compromised. You kick off a massive hunt through terabytes of network logs, searching for any sign of communication with the attacker's known domains. And for the highest-risk organizations, the advice was blunt. Take those Orion servers offline, immediately.
So once you've stopped the bleeding, the real digital forensics begin. Analysts start hunting for the attacker's tactics, techniques, and procedures. Basically, the digital breadcrumbs they left behind. They're looking for things that just feel a little off. A new scheduled task that looks legitimate but isn't. Or maybe the use of a real administrator's account at 3 a.m. to move across the network. It's painstaking work, like trying to find a ghost in a machine that was designed to welcome it inside. You know, the Solar Winds compromise was more than just another breach. It was a massive wake-up call for the entire industry. It really forced a fundamental rethinking of how we approach software, trust, and security. So what can we actually learn from this? Well, there are some huge defensive takeaways. First, the principle of least privilege. A tool like Orion should only have the absolute bare minimum access it needs to do its job, and nothing more. Second, you need visibility. You have to be able to see suspicious activity across your entire environment. Third, modernize how you handle identity and access. And finally, you have to audit your supply chain partners. You have to know who you're trusting. And that really leaves us with this one big, lingering question. We build our security like a fortress, right? With high walls and guards and checkpoints. But what happens when the attack doesn't come from the outside? What happens when it's delivered right through the front gate by a partner you trust? It forces all of us to ask, in a world of deeply interconnected supply chains, what does security truly mean?